I have it on my phone because this summer I needed to look up, there was something I got into at the farm and I broke out really bad. And, yeah, so I had to look up what it was, and that was the only way that I knew how to look up what it was. So I downloaded the app and now I just have it. All right, solve linear systems algebraically. So we can do this either by substitution or by elimination. Overall, my preferred method is elimination, but it really just depends kind of on how the problem is set up. Some problems lend themselves more to one or the other. But to start with, we're going to start with substitution. So the one thing I'll say is, I kind of mentioned this yesterday, but if it tells you you have to use a specific method, you have to use the method that it states, okay? So if it says you have to do it by graphing, you've got to do that one by graphing. If it doesn't specify, you can choose whichever method you like, okay, or which one you think makes the most sense for you to use. I would strongly recommend against using graphing unless it tells you you have to use graphing, because that's the one that people get wrong the most. But again, totally up to you. So, substitution, we'll start with number 4. 3x plus y equals 16, and 2x minus 3y equals negative 4. All right, so, sound like it was about to take off. So with substitution, what I have to do first is I have to get one of the variables completely by themselves. So typically, if I'm choosing to use substitution and not being told that I have to, I'm going to do that only if I have a variable that's already just got either a positive 1 or a negative 1 in front of it. So in this case, I'm going to get y by itself in the first equation. So to do that, obviously subtract 3x. So I get y is equal to negative 3x plus 16. Now at this point, I'm going to take this value here, and I'm going to plug it in for y in this equation to solve for x.
This is what we're doing.
So most of these aren't hard, they're just long, kind of annoying, takes up a lot of paper. So 2x minus 3 times all of this, negative 3x plus 16, equals negative 4. I'm going to distribute, so 2x plus 9x minus 48 equals negative 4. All in this next step, I'm going to combine the x's and I'm going to move the 48 over. So 11x is equal to 44. So x equals 4. So that's the first part. Now I take this and I'm going to plug it back into this equation up here to solve for y.
Oh, yeah.
So y equals negative 3 times 4 plus 16. So negative 12 plus 16 is positive 4. So those are my x and y values, but that's not my answer. My answer is an ordered pair for 4. If you do not write your answer as an ordered pair, you will lose points. A solution to a system of equations is always an ordered pair. Now, I'm not going to necessarily, I'll maybe do it on this first one, but thereafter I'm not going to do it. I'm going to check this one. For the sake of time, I'm not checking them in here with you. I would strongly encourage when you're doing your homework that you are checking them, and when you get to the quiz and the test, you check the point, because you'll know right away if you did the problem right or wrong. Okay? So you can choose either one to check it in. I'm just going to check it in the top one. So 3 times 4 plus 4 equals 16. So 12 and 4, 16 is equal to 16, so I know that that one's good. Eight. 3x minus 4y equals negative 5, and negative x plus 3y equals negative 5. So which one do you think I should get by itself? Yeah, the negative x. So I'm going to subtract the 3y. So negative x is equal to negative 3y minus 5. Divide by the negative, x is equal to 3y plus 5. And just as a reminder, when you're checking equations or checking your points, always check it into the original equation. Because if I did this wrong here and moving stuff around, I'm not going to know, right, that my answer is going to look right. So always check it into the original one so that you'll know if you did it right or wrong. All right, so now I'm going to take that and plug it in for x in the top equation. So 3 times 3y plus 5 minus 4y equals negative 5. Distribute. 9y plus 15 minus 4y equals negative 5. I'm going to move the 15 and combine like terms. So 5y is equal to negative 20. So y is negative 4. And I usually like to circle like my x and y, even though that's not my final answer, so that I don't lose them, because when we get to section 3.4 and we're solving 3 equations with 3 unknown things, which is everyone's absolute least favorite to do, I like to make sure I don't lose where things are because it gets a little chaotic in there. Okay, so now I'm taking this and plugging it into the equation that I solved for x. So x equals 3 times negative 4 plus 5. So negative 12 plus 5 is negative 7. So then my ordered pair, negative 7, negative 4.
It's a negative x, right?
I divided by the negative because you have to have it completely by itself. You're good. So always an ordered pair. All right, another substitution one, and then we'll move on to the next kind. 6x minus 3y equals 15. Negative 2x plus y equals negative 5. So which one do y'all want to get by itself?
The y.
Yep, the y. Now, you can obviously choose any of the variables, but a lot of times you're going to end up with fractions if you choose something other than the one that's just by itself, so just be aware of that. So y equals 2x minus 5, and we're going to plug that in for y in this other equation. So I get 6x minus 3 times 2x minus 5 equals 15. So 6x minus 6x plus 15 equals 15. So move the 15 over. I get 0 equals 0. Any idea what that means?
0?
Infinitely many solutions. They would be the same line if you rewrote them.
So we stop here then?
Yep, and then you write infinitely many solutions. And that's your answer. So you have to show, I could have either just said, okay, 6x minus 6x, and said, okay, 15 equals 15, or I could have gone down what I did and say 0 equals 0 by moving stuff around. If you ever have just a number equal to itself, that always means infinitely many solutions. If you get something like 0 equals to something else, like to negative 5, that means no solution. So those are your two situations that you can have. And in which case you get excited because that's all the math you have to do on those ones. Okay. Moving on to elimination. Number 16. 4x minus 2y equals negative 16. And negative 3x plus 4y equals 12. So with elimination, I'm trying to cancel one of the variables completely. In order to do that, one of the variables, the numbers in front, have to have the same number and opposite signs. So I try to choose the one that I can just multiply one of the equations and get it to look like the other one. Okay? If I chose x right now, there's nothing that I can multiply either of them by, just one of them, and get it to look like the other one. So I would have to multiply both. With y, I can take the top one and multiply it by 2, and I'll have a -4 and a +4 for the two y values, so the y's are going to go away. But it's the entire equation that gets multiplied by 2. So I would have 8x minus 4y equals -32. And then I'd rewrite the other one. -3x plus 4y equals 12. So the y's are going to go away, and then I just add down.
A message for you.
A message for me?
Yeah.
Do not let this go dark, please.
Darn it. It didn't spin. I did.
That's my job.
Okay. I don't know.
No, it's just order like
What'd you do that face? I was like, does she need?
It's a 7 slot. It's a snide little boy.
It's not as bad as yesterday.
Yeah, your eyes don't with water.
Nope.
Did you take medicine? Okay, thank you.
You found the allergy?
I found the allergy.
Huh?
Oh, medicine.
Okay, thanks. Yesterday it did, so I have 2 separate videos from yesterday, so, and it like shuts it off, so that's why I was like, don't let it go dark. Okay. Apparently the message wasn't for me.
Oh.
All right, so now we would just add or subtract or like whatever it is down, just like if you were doing like, 10 minus 5 kind of thing, and you're setting it up that way.
5x equals
Yep, so 5x equals -20. So then x equals -4. Now, the downside to elimination is you don't already have one of the variables to like solve for by itself. But, I mean, that's minor details. You can choose either equation to plug it into. Again, I would use the original equation. Not that I can't use this modified equation, but the numbers are obviously going to be a lot bigger. So if I choose the top one, I want to use this rather than the modified equation. Okay? So do y'all want to use the top equation or the bottom one? The bottom one? Okay. So we'll do -3 times -4 plus 4 times y equals 12. So this is +12 plus 4y equals 12. So subtract 12, so I get 4y equals 0. So y equals 0. So now my ordered pair is -4, 0. And what I typically recommend, if I used the bottom one to plug into to solve for y, use the top one to check your point. Because that way, if you made a mistake over here, you'll pretty much be able to figure it out by using the opposite equation. Again, you don't have to do it that way to check it, but that's kind of what I would typically choose to do if I'm doing it. All right, 18. (4x) minus 3y equals 10, and 8x minus 6y equals 20. So I don't have anything that's already the same number, opposite sign, so I need to multiply one of the equations by something. So, any idea?
Top equation by -2.
-2, yep, because that'll give us opposite signs for sure. And so I end up with -8x plus 6y equals -20. Now, if you're multiplying the top equation and you want to, you can just basically like kind of put a line through it and then just combine them here instead of having to rewrite them all.
Wow.
So 8x minus 8x is 0. Negative 6y plus 6y is 0. 20 minus 20 is 0. So I have 0 equals 0, which means infinitely many solutions. Uh, 22. 7x plus 2y equals 11. And negative 2x plus 3y equals 29. All right, so nothing is already the same number, opposite sign, so I know I'm going to have to do some multiplying. But is there anything that I can multiply one of them by to make it look like the other one?
No.
Without like a fraction, which is going to be a pain, so we're not going to do that. No. So that means I'm going to need to multiply both equations by something. The foolproof method is to take and multiply, like so. Do you want to cancel x or y? Because it really isn't going to matter. Y. Okay. So if we're going to cancel y, then what I would do is I would take whatever number's in front of my y's, and I'm going to multiply this one by this number and the bottom one by this number. But they don't have opposite signs, so one of them has to be negative that I multiply by. Okay? Sometimes when you have big numbers, you don't have to multiply by essentially the opposite one. You look confused.
I am. I don't know.
What is your question?
I don't know my question.
I'll try to show one that like you would have to, or like that could be a shortcut way to multiply it in a minute. Is everybody confused? Okay. I'm going to multiply the top one by 3.
Wait and see what that is.
And I'm going to multiply the bottom one by negative 2. I could do the top one by negative 3 and the bottom one by positive 2. It doesn't matter. I need opposite signs, and I need these to have the same number. So 3 times 2 is 6. Negative 2 times 3 is negative 6, so they're going to be opposites.
Okay.
So I'm canceling my y's. So my top equation is going to become 21x plus 6y equals 33. My bottom equation is going to become 4x minus 6y equals 58, negative 58. So now my y's are canceling each other. So I have 25x equals, is that negative 25? That's nice. And then divide x equals negative 1. So now, which equation, top or bottom, do you want to plug in to find y? Bottom one, okay. So, negative 2 times negative 1 plus 3y equals 29. Again, I used the original equation because it's going to be easier numbers. I could have used the modified as well, but the easier numbers are in the original most of the time. So I've got 2 plus 3y equals 29. 3y equals 27. So y equals 9. So my ordered pair is negative 1, 9. Does that make more sense now?
Yeah, I was just confused about the, like, you said you could multiply this by this, and then I was like, huh? But it makes sense now.
Yeah, sometimes there's easier numbers to multiply them by. I'm not good at coming up with them off the top of my head, but
Like, I understood it, I just was a little lost.
A-okay. All right. The next set of them says that we can choose our method. So I'll let y'all decide which method we're going to use when we do each problem. 28. 3x plus 2y equals 11, and 4x plus y equals negative 2. So do you want to use substitution or elimination? Basically, first method or second method?
First method.
First method.
Okay, so
We're
what am I
finding
getting by itself then?
We're finding y. By itself first.
Yep, so y equals negative 4x minus 2. Take that, plug it in for y in the top equation. 3x plus 2 times negative 4x minus 2 equals 11. So 3x minus 8x minus 4 equals 11. Negative 5x equals 15. So x equals negative 3. So now take that, plug it into the other equation. So y equals negative 4 times negative 3 minus 2. So y equals 12 minus 2 is 10. So y equals 10. So my ordered pair, negative 3, 10. Um, 36. 4x minus 3y equals 8, and negative 8x plus 6y equals 16.
Elimination.
Yeah, I would probably recommend elimination. I mean, you can use, obviously, like I said, another method, but your life will probably be easier if you choose elimination. All right, so what do I need to multiply by in order to make one look like the other one?
2.
Yep, 2, because they already have opposite signs. So I'm going to get 8x minus 6y equals 16. I'm just going to cross that top one out so that I can just combine here. So negative 8x plus 8x is 0. 6y minus 6y is 0. Equals 16 and 16 is 32. Is that ever a true statement?
0 does not equal 32.
So this one is no solution. So on infinitely many and on no solution, you need to show that basically some number is equal to itself for infinitely many, or on a no solution, something like 0 is like this, 0 is equal to 32, or something that's not a true statement where like a number is equal to another number that it's not actually equal to. And you also have to write no solution. Okay? Okay. All right, are we okay on this, or do we need to see any more?
We're great.
Good? Okay. All right, problems. 5, 9, 17, 21, 29, 31, and 35. So the last 3, you can choose your method. Now, it says any algebraic method, so that means not graphing. But you can choose your method on those ones.
So solve